All right, everybody, 1.6, describing pairs of angles. We got a couple things we're going to discuss here. Complementary, supplementary angles, linear pairs, and vertical angles. So without further ado, let's get through this and see what we got here. All right, so I'm going to jump a few slides. So first, a couple definitions. Adjacent angles, two angles that share a common vertex but have no common interior points. All right, so in a nutshell, what does that mean? Pretty much two adjacent angles are two angles that are going to be right next to each other. So here's one angle, and they share a common side, right? And they share a vertex, and they have a common vertex there, right? They have to be right next to each other. They have to share that piece. These angles here, 7 and 8, are not adjacent angles because they are not on a common. They don't have a common vertex, right? Here's a vertex here. Here's a vertex here. So they have two different vertices. So they are not adjacent angles. Complementary angles. All right, so we talked about complementary a little bit. Complementary are two angles that make a right angle, or 90 degrees. Right, so complementary angles, angle 1 and angle 2 together add up to 90 degrees. Right, they don't have to be on. They don't have to share a common vertex. Okay, complementary angles can be two separate angles with two different vertices. All right, as long as these, as long as the two angles together make 90 degrees, they are considered complementary. Right, so complementary angles, sum of 90 degrees. And then on the flip side, we have supplementary angles. Right, these are two angles that have a sum of 180 degrees. And again, they can share a common vertex. They could be adjacent to one another, so right next to each other, like these are. All right, so one of these, the angle 3 and angle 4 together add up to 180. Or supplementary angles can be two separate angles from one another. They don't have to share the same vertex, but the sum of these two angles still makes 180, so they are considered supplementary angles. So in this case, angle C and angle D are supplementary. Angles 3 and angle 4 are supplementary. Angles 3 and angle 4 are also adjacent. All right, and likewise with angle 1 and angle 2, complementary and also adjacent. A and B not adjacent angles, but since they both add up to 90 degrees, they are both complementary. Alright, so let's do this, figure out a couple pieces here. So it says, in each figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So let's go with complementary first. Alright, two angles here that make 90 degrees. So I'm going to highlight angle CAB, which is 37, and angle RST, which is 53. And 53 and 37 gives you 90. So my complementary angles here are CAB and angles RST. These are my complementary angles, again, because CAB is 37 degrees and RST is 53 degrees. And the sum of those two together is 90 degrees. The supplementary angles here. Alright, I'm going to take this again. And my supplementary angles here, I'm going to take this CAD, which is angle CAD here, which is 127 degrees. And then I'm also going to take again angle RST plus angle RST, which is 53 degrees, giving me a grand total of 180 degrees. Again, they don't have to be next to each other. Two separate angles, two different vertices, but as long as they sum up to be 180 degrees, they are supplementary. Then adjacent. Adjacent angles have to be next to one another. They don't have to equal anything. They just have to be next to each other. So what are my two angles that are next to each other? Well, I'm going to automatically not include RST because that's completely separate, has a different vertex. But here's a vertex of A that's shared by angle CAD, shares that vertex A, and CAB also shares that vertex. And again, they don't have to equal 90 or 180 or anything, they're just adjacent angles. Alright, example 2. It says angle 1 is a complement of angle 2, and find the measure of angle 1. The measure of angle 1 is 62 degrees. The measure of angle 2 is find. We're going to figure that out. Alright, so if this is a right angle, because it's saying complementary. So somewhere in here is an angle 1. Right, we'll call this angle 1, and I'm just estimating about 62 degrees in here. And this angle here, we'll call this angle 2. Angle 2 is the complement of angle 1. So how do I find this angle 1? Well, I know that angle 1 plus angle 2 are going to equal 90 degrees. Angle 1 is 62 degrees. And with a little subtraction here, subtract 62 from both sides, and I'll get angle 2 is equal to 28 degrees. Right? Or just 90 minus 68, which will also give me 28 degrees. Okay? So complementary angles again, totaling 90 degrees here. Right? What about supplementary? Right? Supplementary again is two angles that make 180. So a straight line makes 180 degrees. I have an angle 3 and angle 4. Angle 4 is 47 degrees, so I'm just going to estimate here. Let's say this is about 47 degrees here. And then this is angle 4 here. And angle 3 is here, the unknown. Right? But I do know that angle 3 plus angle 4 are supplementary, therefore equaling 180 degrees. Angle 3 is my unknown. I'll just call it angle 3 for now. Plus my 47 degrees is equal to 180. Subtract 47 from both sides, and you get 133 degrees. And then double check my work. 133, 147 is a total of 180 degrees, which is a straight angle. And again, angle 3 and angle 4 share a common vertex here. Okay, so angle 3 is coming this way, angle 4 is coming this way. Those are also adjacent, so they are adjacent and supplementary. Alright, next example, example 3. When viewed from the side, the frame of the ball return net forms a pair of supplementary angles. Alright, so there's the word supplementary. I'm automatically thinking that there's two angles that equal 180 degrees. Alright, find angle BCE. So here's BCE, so I'm looking for this angle here. And ECD, so I'm also looking for this angle here. So what do I know? I know angle BCE plus angle ECD are supplementary, so they both together equal 180 degrees. BCE is given to me as an expression of 5x plus 10. ECD is also given to me as an expression as 3x plus 2, and the sum of these two expressions is equal to 180. Combine like terms, 5x and 3x, 8x, positive 10, positive 2 is positive 12, all equal to 180. Little two-step equation here, subtract 12 from both sides, you get 168, and then divide both sides by 8, and you get 21. So this is 21, not 21 degrees. Alright, so take it a step further. It's asking for each angle. So what I'm going to do is I'm going to plug in that 21 in for x. So I got 5 times 21 plus 10, which is 105 plus 10, which is 115 degrees. So this angle here is 115 degrees. And you get this other angle here by just doing 180 minus 115. Or, again, you could plug into 21 for x here. Either way is fine, but you end up with the same thing of 65 degrees. Here's a couple problems you can try on your own. I would pause the video at this point and try numbers 1, 2, and 3. Move on to the next slides and show you how to complete these. But pause at this minute, pause at this point, try these on your own first, and then go back and play the video again. All right, so here's the first one. Name a pair of complementary angles. Alright, so again, two angles that equal, complementary is two angles that equal 90 degrees. And I see that angle F, let me go in red here, FGK is 41 degrees. So now FGK is equal to 41. And there's FGK, I'll go in red there. And then in green, I got GKL, which is 49. Angle GKL, which is 49. And 41 and 49 is 90. All right, a pair of supplementary angles. Again, supplementary is going to be angles that equal 180 degrees. So I'll just put this in parentheses. 180 degrees. Complementary is 90 degrees. Alright, so I'm looking for, I'm going to erase this stuff here, erase what I wrote. Okay, and now I'm looking for my supplementary angle, so what two angles will give me 180, so I'm going to take this bigger angle here, so I'm going to do HGK, angle HGK, which is 131 degrees, and I'm also going to take this 49 degree angle here, which is GKL, angle GKL, and which is 49 degrees here. Add the two together and you get your 108 degrees. And then lastly, again, I'm just going to erase what I have. And then lastly, the last piece here is adjacent angles. Alright, so they have to share the same vertex. I see this angle here. This is the vertex. There are no other angles that share that vertex K, which leads me to believe that my my adjacent angles are going to come with this one. So FGK and HGK both share the vertex of G, common side of GK. So FGK, so the adjacent angles are angle FGK and angle HGK. Alright. Next example, are KGH and LKG adjacent? Alright, so KGH, KGH, alright, sharing this, and this is your vertex, and the fact that it says LKG, that's an indication that they're not sharing the same vertex here, so automatically, without even going through this, I can see that the vertex should be the same. It's not the same, so are they adjacent? So for the first question, no. Second question is FGK and FGH. Well, now look, now they both have that common vertex of G, so that's on the right track, but let's just take a look at it anyway. So FGK is this angle here, and in blue here, I'm going to do FGH, FGH, not adjacent angles, right? So this is FGH is the entire angle, FGK is this angle, FGH is that angle, so those are not adjacent angles either. Which ones are the adjacent angles here? So I'm just going to erase some of this work here. Alright, so which ones are the adjacent angles? So FGK and angles HGK are the two adjacent angles here. Angle 1 is complementary to angle 2. Find the measure of angle 2 is 5 degrees. Find the measure of angle 1. So if angle 1 is a complement, then that means there's 90 degrees. So that means angle 1 plus angle 2 has to be 90 degrees. They gave me some information here that said angle 2 is 5 degrees. So angle 1 plus 5 degrees is 90 degrees. Well, what plus 5 degrees is 90 degrees? Angle 1 is equal to 85 degrees. I don't need this image here. Angle 3 is a supplement. Supplement, again, 180 degrees. Angle 3 plus angle 4 is equal to 180 degrees because of the supplementary. Given information, angle 3 is 148 degrees plus angle 4 is equal to 180. Subtract 180 from both sides, and you get angle 4 is equal to 32 degrees. Alright, moving right along. Again, please pause as you need. Alright, angle LMN, PQR are complementary angles. Good. They don't share the same vertex, and they don't have to. Right? If they share the same vertex, they could potentially be adjacent, but complementary and supplementary angles do not need to share the same vertex. But they're saying they're complementary, therefore implying that there's two angles that total 90 degrees. LMN is my first angle. So 4x minus 2 being my first of my 90 degree angles, or plus angle PQR, which is 9x plus 1. Sum of these two angles together will give me my 90 degrees. Solve for x, combine like terms. 13x minus 1 equals 90. 13x equals 91 when you bring over the 1 here. And 13 goes into 91 7 times. Once you have the 7, please make sure you go back and identify the angles here. So LMN is 4x minus 2. So in this case, it's equal to 4 times 7 minus 2, which is 28 minus 2, which is 26, which implies that angle PQR is going to equal 90 minus 26 degrees, which is 64 degrees. A couple more key ideas in this lesson here, 1.6. Two adjacent angles are a linear pair. Okay, so if you have two angles or supplementary, right, so on a straight line, they're supplementary to one another, angle 1 plus angle 2 is going to equal 180 degrees, and so supplementary and adjacent, meaning they share the common vertex, so twofold, then we're going to refer to those two angles as a linear pair. So this line here, right, this is my line, linear pair, they're right next to each other, and they form 180 degrees. Right? And then the next key idea here is vertical angles. Right? When they're sides of two pairs of opposite rays. So here's pretty much just forms an X or T, but these are your vertical angles. And what's happening here is angle 3 and angle 6 are the vertical angles, and because they are vertical, they are also congruent. And this will happen all the time with vertical angles. So vertical angles are always congruent to one another. So angle 4 and angle 5 are now congruent to one another. Notice I put the one arc to show that 3 and 6 are congruent, two arcs to show that 4 and 5 are congruent. So 3 is vertical to 6, 4 is vertical to 5, 3 is congruent to 6, 4 is congruent to 5. Alright, so here's a couple examples. It says identify all the linear pairs. Alright, so for linear pairs, again, I'm going to look for every straight line I see. So I'm going to start off with this line right here. Okay, linear pairs are in groups of 2, and on this straight line here, there I see 3 angles here, 1, 2, and 3, and I only want pairs of 2. So linear pair is not 3 angles, it's 2 angles. So on that straight line, I don't see anything on top that's a linear pair. But if I look below the line, alright, I'm just going to erase this piece here. If I look below the line, I like the bottoms of this line, 4 and 5 are on that line and form a pair. So on that line right there, angles 4, so linear pairs, angle 4 and angle 5 are a linear pair, meaning that angle 4 and angle 5, the sum of them together is also 180. Right? So angle 4 plus angle 5 is going to equal 180 because they're a linear pair. So that's my first group of linear pairs. Alright, so I took care of this line here. I'm just going to put a little check here. Done. Alright, then I'm going to look at another line here. My other straight line that I see here is this line here, straight across this way. Alright, and I'm going to look on both sides of the line and try to identify any linear pairs. So when I look at this top part of the line, there's 3 angles here, 2, 3, and 5. That's not a pair, that's a trio, so that's not going to work. So I don't care about that part. And then I'm going to look below that line on this side here. And what do I see? I actually see 2 angles. I see angle 1 and angle 4 that together form that line. So angle 1 and angle 4 are on this line here, right? They are right next to each other. They are adjacent to one another. They share a common vertex. They are on a straight line. Straight lines equal 180. So angle 1 and angle 4 are also a linear pair that gives me 180 degrees, right? And then I got one more line, so I'll check off this line here, and then let's see what else we got. And then those are all the lines that go straight through. This line doesn't go all the way through, it's just here, so there's not going to be any linear pairs through that one. All right, and then last, and then it says identify all the vertical angles. So I'm going to look for anything that forms an X here, and I do see an X in this picture. I see an X formed by this line and this line here, and 1 and 5 are vertical to one another. Okay, and 4 is not vertical to 2 or 3. Right? 4 would be really just vertical to 2 and 3, but that is not. But that's not a vertical angle. Vertical angles are just pairs. So 1 and 5 are the only vertical angles that we see here. If this wasn't here, if this ray wasn't here, then if this ray wasn't here and this was just angle 6 here, then 4 and 6 would be a vertical pair, or vertical angles as well. But in this case, it's only angle 1 and angle 5. There are the vertical angles here. So my vertical angles are angle 1 and angle 5, which implies that angle 1 is congruent to angle 5. They're going to have the same exact measurement. Alright, next example. Two angles form a linear pair. Alright, again, definition of a linear pair is two angles that are right next to each other. Two angles that are right next to each other that share a common vertex. Right, and the two angles are 1 and 2 right next to each other, which is exactly what I have here. Here's two angles that share a common vertex here. Here's the first pair. Here's the second pair. The fact that they form a linear pair means that there's a straight line somewhere. This straight line is always going to measure 180 degrees. So what's going to equal 180 degrees? It's going to be the linear pair of, or the pair of angles, that's 5x plus x together, going to equal 180 degrees. So pretty much they're just supplementary angles that share the same line and vertex, and they're next to each other. Right? So you're going to solve this out. 6x equals 180. Divide both sides by 6, and you get x equals 30. Find the measure of one angle. This one also said the measure of one angle is 5 times the measure of the other. So we have a diagram here. The measure of one angle is 5 times the measure of the angle of the other. This is the other angle. So when we reference the other angle, it's always in terms of x, and then there's always some information about one of the angles in reference to the other angle. So if the measure of one angle is 5 times the measure of the other. Okay, so here's the one angle, that's 5 times the measure of the, and here's the other angle. All right, and we'll see some word problems like that as we come across a couple more examples here. All right, and then the x equals 30, so this one's going to be 30 times 5, or 150 degrees, leaving this one to be 30 degrees, getting a total of 180 degrees. Here's another example for you guys to try. This one's identifying a linear pair in vertical angles. All right, so linear pair are going to be two angles that make 180 degrees. Alright, so if I highlight every straight line here, I'll start this one, and I look at all the angles created above this line. Alright, so if I'm looking at the top of this line, here's angle 1, angle 2, angle 3. So there's 3 angles above this line that combined make 180 degrees. For a linear pair, it has to be 2 angles. So 1, 2, and 3 are not a linear pair. If I look below the line, I get 6, 5, and 4. Again, 3 angles. That's not going to work for me. And if you look at any of these lines, they're always going to be based off of 3 angles no matter what. So you're not going to see any linear pairs in this one. Alright, but we do see some vertical angles here. And can you identify the vertical angles? Okay, so look for the x's, right? So here's an x. So this line goes all the way down this way. This line goes all the way down that way. There's the vertex. So angle 1 and angle 4 are called vertical angles. Therefore, angle 1 and angle 4 are also congruent to one another. And if I use that same x here that I'm looking at, so using this x here, I said 1 and 4. Alright, and then if I went this way, right, using that diagram here, I wouldn't have another set of vertical angles on that one. I would have more than one angle in there. So let's see if I can find another pair of vertical angles here. So we said 1 and 3, and I'm just going to label these ones. So 1 and 4 vertical angles. We can see that, maybe you can see that 6 and 3 are vertical angles. And then lastly, 2 and 5 are vertical angles. Right? So 1 and 4 are congruent, 6 and 3 are congruent, 2 and 5 are congruent. Here's another question. This time I did not give you the measurement here. Alright, so it says measure the angle. The measure of an angle is twice the measure of its complement. Alright, so first thing I'm looking at is the fact that it says complement. Complement think. Alright, so I'm automatically thinking I have a right angle here. Okay, so you have a right angle, and the fact is that it's complement, right? There's some kind of complementary angles here. I'm splitting this angle up into two angles, right? And both these angles here are going to equal 90 degrees. So it says the measure of an angle is twice the measure of its complement. Well, I don't know one of the angles. Well, the other angle is twice the measure of its complement. So if x is the angle, then that's the other angle is going to be 2 times x. So 2 times its complement. So x is complement. This one's going to be 2 times its complement. So 2 times x. So now I know that one angle is 2x. My second angle is x. Both those angles together is 90 degrees, or 3x equals 90, x equals 30. So this one's going to be 2 times 30, or 60 degrees, and this one's going to be 30 degrees, giving me a total of 90 degrees. Next one, two angles form a linear pair. Linear pair, I'm automatically thinking a straight line, and there's another angle somewhere in between here, and making this a linear pair sharing the same vertex. Right, they're adjacent and supplementary in a sense. The measure of one angle is 1.5 times the measure of the other angle. Okay, so there's an angle that I don't know, and there's another angle that is 1.5 times the measure of that one, so 1.5 times that angle. Okay, so that means these two angles, the angle that's 1.5 times the other angle, the total of these, so it's going to equal 180 degrees. And then I'm going to do 1.5 or 1 1/2 plus 2, or plus 1, so I got 2.5x equals 180, and then divide both of them by 180 by 2.5, which means that x is going to equal to 72. And in this case, x is my angle here, so it is 72 degrees. Alright, and then the other one's just going to be 1.5 times 72, which is 108. Or you could have done, since this one's 72, then this angle here has to be 180 minus 72, which again is 108. Alright, so that's all we have for lesson 1.6. Hopefully you're taking notes. Look for the homework posted on the Google Classroom. See you guys on Monday.